Hey everybody, in this video, now that I've set a foundation, I've done 4 videos. I've talked about finding answers between an interval like 0 to 2 pi, as well as all solutions. I'm going to see if I could do 2 examples in one video, as long as I could kind of keep it under 10 minutes. So if not, I'll just separate this into 2 different videos. The directions for this set say solve a trigonometric equation in the interval 0 to 2 pi, use the hints provided. Hint on number 5 says rewrite with single trig function. Okay, so when it's like this, you can't factor this the way it is right now. If I can make it look a little bit more like number 4, the most recent video on the playlist, where I could get it to look like ax squared plus bx plus c, the thing is, like, your x has to be the same type of trig all the time. Now, you could be quadratic and not have a bx. It could just be ax squared minus b, like a difference of 2 squares type of thing. That's fine. So that would be like number 2 on this set. So we have to get rid of something. Now, if you look, I have secant squared and tangent squared. And if you think about the Pythagorean identity, we should know that we have tan squared theta plus 1 equals secant squared theta. That's a Pythagorean identity. That's a classic identity, a fundamental identity, and we can use that anytime, anywhere, interchange it, anything we want, and clean it up. So what we could do is I can find secant squared over here and sub in tan squared plus 1. And what that will do for me is give me an equation that only has tan in it instead of tan and secant. Okay? So I'm going to sub in. I'm going to get 3 quantity of. Stop being a weirdo and not using parentheses. I don't know what that's all about. 3 tan squared theta plus 1 in parentheses minus 2 tan squared theta. I switched it to theta. It's x. It's the same thing. Minus 4 is 0. I'm going to distribute that 3. 3 tan squared theta plus 3 minus tan squared theta. Normally, honestly, I would write that underneath that. Oh, 2 tan. Because it makes combining like terms like easier. I don't lose anybody and nothing gets lost in the world. Minus 4 is 0. And what do I mean by that? Whenever I'm doing my work normally, I would do this. 3 tan squared theta plus 3, and since this is on the same side, minus 2 tan squared theta, and then minus 4 equals 0, and then I combine like terms like that. I just find it to take up less room this way. I find that I don't miss any terms or anything like that. So that leaves me with a 1 tan squared theta, or tan squared theta. 3 minus 4 is minus 1 equals 0. Now I could solve this one like we did with number 2, where we extracted square roots. But in the second method I did for number 2 on that same playlist, on the same video, I factored it like difference of 2 squares, and I said I like that way better because when you factor to solve, you'll never miss the plus minus, but when you take a square root, you're more likely to forget to put the plus minus out front that you're supposed to put whenever you take a square root yourself, and then if anything you would eliminate one if it's an extraneous solution. I would set each of these then equal to 0. So set that equal. Don't put the other equation under it. Just keep your work underneath each of the parentheses, because then all the work that information, everything that pertains to that, where it came from, will be right under it. So like underneath here, I have tan theta equals -1. Underneath here, I have tan theta equals 1, right? Now again, this one, the direction said solve on the interval 0 to 2 pi. So I'm only looking on one, loop-de-loop around of the unit circle. So what's the question you're asking? The tan of what angle or angles will give me an answer, an output of -1. So what input, what angle, tan of what angle will give me -1? Well, tangent equals 1 at all the pi over 4s, and tan is positive in quadrants 1 and 3, so positive 1 here and here, and it's negative in quadrants 2 and 4. So what are the answers over there? They are 3 pi over 4 and 7 pi over 4. So that's 1, 2, 3 pi over 4, 4 pi over 4, 5, 6, 7 pi over 4, 8 pi over 4 makes 2 pi, okay? For anyone that's a rookie. Theta equals, and then when is it positive 1? We said here and here. So that one is 1 pi over 4 or pi over 4. And if that's 4 pi over 4 for pi, the next one after that is 5. That's a 5. I don't know what that scribble was. 5 pi over 4. And there you go. If you want to write your answer as a set, you would write in order pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And there you go. All right, that's the end of that one. Where are we? Less than 5. All right, let's keep it going. Switch my pen color for this guy. All right, now this one is very similar to the last one, but it has just a little extra something. So if you notice, we have sine and cosine who also share a Pythagorean identity, right? We know that sine squared theta plus cosine squared theta equals 1. But contrary to popular belief, guys, you cannot swap things in and out unless it's sine squared and cosine squared. It has to be the correct one situation, whether it's plus or minus, wherever it is. You cannot just go all willy-nilly and swapping things in and out, okay? So we can't plug anything in and out right now the way it is. It's not going to help me. If that was a cosecant, I can make that 1 over sine and then multiply that sine over to the other side. There's stuff I can do. But it's sine and cosine who share a Pythagorean identity. So what am I going to do? I'm going to square both sides. Big warning though. Anytime you square both sides of an equation, you're going to go in your mental time machine right now. In Algebra 2, anytime you solved an equation by squaring both sides, you were responsible for checking for extraneous solutions. I'm going to repeat that. Anytime you solve an equation by squaring both sides, you are responsible for checking for extraneous solutions because you went from a restricted type of graph, and when you square it, you create more solutions than what were there originally, okay? And it makes it, that's the whole plus minus when you take a square root, right? Where we like have to decide, do we want both answers, one answer? But when you square both sides, you're putting everybody in play, right? You're putting all the kids on the field. But we got to be like, oh, hold on. You can only have 5 players on the court at a time. What are we doing? So we're going to square both sides. Again, you have to check for extraneous at the end, okay? If I square the right side, that one's pretty easy. It's just cosine squared theta. When you square the left side, God help you if you write sine squared plus 1. I will not forgive you, okay? You are better than that. You have to write it twice. You have to FOIL. I would hope at this point in your life that you could FOIL in your head. It's sine theta plus 1, sine theta plus 1. I'm not writing it out. You're a big boy. You're a big girl. You do it. Pause it. You do it on the side if you need the minute. So I get sine squared theta plus sine theta, sine theta. I get 2 sine theta. 1 times 1 is 1, even though a lot of people accidentally put 2. So there I am. Now, I want to get rid of one of these and put in just all sine or just all cosine. The way you decide is, since I have a sine to the first power, I can't really do anything with that. I can't get rid of it. So I'm going to get rid of the cosine squared and fill in that cosine squared theta is equal to 1 minus sine squared theta. So I'm going to fill that in over there. So what do I have on the left? Sine squared theta plus 2 sine theta plus 1 equals 1 minus sine squared theta. Now what else is the rule when we have polynomials that we're going to factor? We got to get it equal to 0 first. So that's gone. And then add sine squared theta to both sides. So there I have 0, 2 sine squared theta plus 2 sine theta, and then that happened to cross out. Now it's sort of like example 3 on this playlist, right? Where we were able to factor out a GCF and it was like cosine theta or something like that. So I'm going to factor out a GCF. It's not ax squared plus bx plus c per se because my c is 0. If you notice, I don't have the constant at the end. So I'm going to take out my GCF. Not only is my GCF sine theta, but it's also 2 sine theta. We like to take out the greatest common factor, not just a CF, a common factor. So again, I'm going to underline the thing I'm taking it out of. That's 2 sine theta. I'm going to multiply that thing essentially out front or put it out front. So I have 2 sine theta. And then I'm going to pretzel to reduce. The 2's are gone. Sine squared over sine. I'm left with sine theta plus the 2's are gone. The sines are gone. It's not 0. It's 1 equals 0. So that's where I am. I'm factored. It's equal to 0. Happy little 0 if you're happy and you know it. Clap your hands. And now what you're going to do is the 0 product properties. We're going to set each part of this factored form equal to 0. So I have 2 sine theta equals 0. Divide by 2, I have sine theta equals 0. Over here, you have sine theta plus 1 equals 0. Subtract the 1, you have sine theta equals negative 1. So you ask yourself the magic question, the sine of what angle, what input do I need to give me an output of 0? And the question only wants directions say answers between 0 and 2 pi. So where is the y value equal to 0? Well, at 0 and at pi. Again, we don't include 2 pi because there's a parenthesis on the 2 pi, a bracket on the 0. The 0 is included in my possible answers. 2 pi is not, it's excluded. And then where is y, or the sine value, equal to -1? The sine of what angle is equal to -1? And the answer to that is when theta equals this guy right here, which is 3 pi over 2. Winner, winner, yummy dinner. Okay? Those are your three answers. Again, if you wanted to list them, you would do 0, comma, pi, comma, 3 pi over 2. Close your cutesy little bracket, and there you go. Beautiful. Hope you love it. So if you're feeling good, feeling smart, you know, thumbs it up. If not, thumbs it down. Questions, comments, concerns, requests, you can put in the comment section, and I will try to make your wish come true. Okay? Bye for now.